Hi everyone, I have a simple question for you. I have a glass of water here and I'm going to put some ice in it and the water level will rise. And the question is, what will happen to the water level after all the ice melted? Is it going to stay the same? Is it going to increase or is it going to drop? Okay, you can pause here and you can guess the answer. And I will answer this question with two methods. The first one is just to take the water here and to mark the level now. Okay, so I'm going to do just there. Right. The first method is really simple. We just wait now, right? The second method is to do the maths. Okay, how do we do that? Okay, well, let's start from the beginning. So we started with a glass of water, and I'm going to assume that the water glass, the glass is cylindrical. I'm going to give just some numbers. So I'm going to say the volume of the water is 300 centimeters cube. And I put some ice in it, so it's the same glass, but what will happen when I put some ice in it? Don't mind that. Okay, so here I have an ice cube, and for simplicity, of course, I'm going to assume there's only a single ice cube in the water, but you know, the water level now increased, and I'm going to call this whole height of the water D. And now the new volume of the water is going to be pi dr square, which is the volume of a cylinder. Okay, so, and then the third situation, which is the same glass, same container. Now the whole of the ice melted. I don't know, perhaps we can just do this melted ice somewhere around here. So now I have this new length here, d dashed. And now the volume is pi d dashed r squared. Okay, so basically the question is, what is the difference between d dashed and d? Okay, how do we find this? Well, we start with d. Let's write a equation for this expression for this volume here. Well, what is it equal to? Well, that equals 300 centimeter cube, that one, plus whatever the level raised, there is a displaced water with some volume, and that volume is going to be the same volume that the ice occupies that space in the water, which is going to be H, so HLW. Okay, so I should say that ice cube has dimensions height. Where do I draw? Let's draw here. So you have, okay, you have H, height, V and W and L. Okay, and they are, let's say they are all the same, 4 centimeters. Okay, so that H we don't know. Okay, so you have 300 centimeter cube plus HLW. And so if I basically, just to find H, D, I mean, I need to divide everything by pi r squared. Okay, right, obviously we need some data. What we need is the radius of this cylinder, which is r equals 3 times 10 to the minus 2 meters. Okay, so we're going to work in meters, and so we need to convert everything into meters, and I'm going to start with centimeter cube. And if you have an embarrassing secret about how to convert things, you don't need to see a psychiatrist, just start from the beginning. So 1 centimeter is going to be what? 10 to the minus 2 meters. Then 1 centimeter cube, the whole thing is cubed. So 1 centimeter cube is 10 to the minus 6 meter cube. Okay, so we have done the conversion, and 4 centimeter is 4 times 10 to the minus 2 meters. We just sub in the numbers. Notice that we still have something that we don't know, and that is h. Okay, but let's write everything we do know. 4 times 10 to the minus 2 h divided by pi times r is 3 times 10 to the minus 2 squared. Okay, so how do we find h? Well, to find h, we need 2 things. Okay, one is one of the greatest prophets, physicist, said that that if an object is at rest or at constant motion, then the forces are balanced. And of course, that was Sir Isaac Newton. And the second one is Mr. Archimedes, who said that the upthrust force equals to the weight of the displaced water. Okay, so let's call U to be upthrust. Okay, so what Newton is saying, that U equals the weight of the ice cube and then what Newton says, U equals, sorry, what Archimedes says, U equals weight of the displaced water. Therefore, weight of the ice cube equals weight of the displaced water. Okay, right, so I'm going to use this bit here. Basically, this is going to tell me what h is. Right, so mass of ice times g is the weight of ice cube equals mass of displaced water times g. Okay, so g's cancel, so mass of ice equals mass of displaced water, and you know the density equation is that, which means we can write mass as rho v and substitute all that here. So I have density of ice, volume of ice equals density of water, volume of water, displaced water. Okay, so let's write that is h H L W and volume of the water, displaced water, is HLW. So I have some cancellation here again. So cancel those. So I have H equals, right, equals rho ice divided by rho water times H. Okay, so now I can find H. I know I didn't tell you, but actually we do know the densities as well. So rho ice is 900 kilogram per meter cube, and rho water is 1000 kilogram per meter cube. Okay, so in fact when we put in the numbers here, I'm going to get H equals 900 divided by 1000 times 4 times H is 4 times 10 to the minus 2. Okay, and that will give me, well, you can check that, but I believe it's going to be 3.6 times 10 to the minus 2. Okay, meters. That's H. Now I can put H here. Okay, and calculate D, and I find D is going to be 0.126. Okay, right, you can check, do the calculation, check that you get that. So we found D, and next we're going to find D dash. Okay, so what I will do is pick up that cap and clean some space. I think that Sir Isaac Newton and Archimedes can go. Okay. Ooh, my second method also is working. I'm very happy to announce, but I'll show you at the end. Okay, so D dash. Hey, okay, so how do we find D dash? Well, it's actually very similar. We just write what that volume is going to be. So pi D dash R squared, the volume of the water plus the volume of melted ice. Okay, so at this point, maybe I should say that the mass of the ice is the same as mass of the water. In other words, the amount of ice molecules here will be the same as the amount when it melts. However, the volume of ice is not the volume of water. Melted, let's say melted ice. Actually, I want to be totally clear. Okay, so mass of ice cube is same as mass of melted ice. Volume of ice is not the same as the volume of melted ice. Density of ice is not going to be the same as density of melted ice. Okay, so this is why we can't just say that volume of the melted ice is going to be the same of the whatever the volume I have here as ice cube. So we need to calculate here. We don't know what the volume of melted ice is. Once we know that, then we're going to be able to say, to calculate D dashed. Okay. Okay. So first of all, we find the mass. Okay. And I have, of course, enough knowledge to do that using the ice cube, because I know the density of ice cube. Okay. So remember again, mass is rho times density. So mass is density is 900 kilogram per meter cube. Volume of ice, we know they're all, the dimensions are 4, so basically 4 times 10 to the minus 2 cube. So I have basically 900 times 64 and times 10 to the minus 6, and that gives me 0.0576 kilogram. Okay, so I know that the mass is the same, so now I can calculate the melted ice, the volume of melted ice, because I know the density of the water. Okay, once it becomes water, so that's what I use. Melted ice is going to be m divided by density of water, which is 0.0576 divided by 1000. So that's going to be 5.76 times 10 to the minus 5 meter cube. Okay, so now we can calculate d dashed. So that is going to be 300 times 10 to the minus 6 plus 5.76 times 10 to the minus 5, all divided by pi r square, which is pi times 10 to the minus 2 squared, and this is going to give us, you can check that with your calculator, it is going to give us d 0.1.126, and now I wiped it, but you can see, go back and see that d was also 0.126, so d dash minus d is 0.1, it's 0. Wow. Now, if you don't think this is cool, I think you should see a psychiatrist, okay? This is so cool, right? And it's very surprising. You have some amazing properties of water, and one of them is that ice cube floats, as we started here, and of course you all know this, we've seen it, we see it every day. But this is not the case for all substances. Suppose, for instance, I had, instead of water, suppose I had iron, liquid iron, and I put a box of iron inside the liquid iron. What will happen? That it will sink. It will go to the down and sit on the at the bottom. And the reason is that because the density of solid iron is greater than the density of solid iron liquid. And normally most substances are like that because of the particles movement, as particles inside the substance, as the substance gets cooler, the particles inside the substance get closer together, and meaning that their volume is decreasing, also their density is increasing, and so they become they have bigger density, and this is why they sink if the density of the liquid is less. Water does the same thing. As you cool down water, it starts contracting. Molecules in the water get closer together until you hit 4 degrees Celsius, then something incredible happens. They start doing the opposite. So you go below the 4 degrees Celsius, then the water molecules, which become in ice now, they start expanding. Wow. So as a result, density of ice is less than density of water, which is why you get ice cube floating like that, and which is why also you can think of it when you put the ice. You imagine you took it out and you made a hole inside the water where ice was. So ice melts in such a way that it fills in this hole here. Yeah, as though ice cube knows how much space there is there, and it fills exactly that hole, and the level stays the same as it melts. So I think that is really amazing. I will leave many links down. You can go and check them out, read them. And by the way, I think this worked. I'm not sure how visibility is good. The ice melted and the level didn't rise. So next time you're drinking water, just pause and think what a wonderful thing this is, right? See you later.